Alright, so hopefully you recognize this. This is a quadratic and it's in vertex form. And we can pull a couple pieces of information out of this. We can pull the vertex, and that's why it's named that. And that's simply from this number here and this number here. So the vertex in this case, I take the number on the inside, and remember it's always opposite of the sign that you see on the inside. So the vertex here would be -5. And then on the outside is my y-coordinate, so that's -1. So there's my vertex. The last couple of days we've been talking about just looking at this side and simplifying it a little bit. So let's go ahead and go through that process. So anytime I see a binomial squared, that means that there are two of these terms being multiplied together. So let's go ahead and write that out. So I get x plus 5, there's 1, and I'm multiplying that by another x plus 5. So this is just another way to say x plus 5 squared, and then I have a -1 tacked onto the end of it. So in order to deal with this, this is basically we have to distribute twice, or commonly known as FOIL. So x times x is x squared. X times 5 is 5x. 5 times x is also 5x. And then 5 times 5 is 25, and I've got my -1 tacked onto the end of it. Go ahead and simplify and combine, and I've got x squared plus 10x plus 24. We've now taken this, and we didn't really change anything about it. We just kind of simplified things, and we have this equivalent expression, or equivalent equation, I should say, where it's just in a different form. And this form is called standard form. So we've taken this vertex form and we've converted it to standard form, and we want to look at what are these things, what are some of the properties that this thing has. We already know that it has a vertex at -5, -1. But how can we deal with the standard form, and why is it useful? So that's what we're going to look at in this video. So a couple more examples of that. Let's go ahead and do this one. So x minus 2 squared means that I'm taking two of those x minus 2's, multiplying them together. And when I do that, I'm going to FOIL this, and I'm going to get x squared minus 2x minus another 2x. And a negative times a negative is a positive. 2 times 2 is 4. And then we want to combine like terms. So an equivalent way of writing this quadratic here is x squared minus 4x plus 3. So this is in what we call standard form, and it's exactly the same as this original one, it's just in a different form. So the last example, you'll notice there's a number in front, and so we kind of have to pay attention to the order in which we do these things. So we just want to take this vertex form of this quadratic and convert it to standard form. And in order to do that, I'm going to apply my exponent first because of that order of operations. So I go x minus 1 times x minus 1. I'm going to go ahead and FOIL this out. When I do that, we're going to leave that 3 out front. When I FOIL this, I'm going to get x squared minus x minus another x plus 1 on the inside. That plus 2 is still hanging out there on the outside. That's equal to 3, so let's go ahead and simplify on the inside here. Inside the parentheses, x squared minus 2x plus 1 on the inside of the parentheses. And now I can go ahead and distribute that 3 just to get things a little more simplified. So this 3 has to get multiplied by every single term on the inside. So when I multiply 3 times x squared, I get 3x squared minus 6x plus 3. I've expanded that whole thing, and then I've got this plus 2 tacked onto the end. And finally, we can combine our constant terms there, and I get something that looks like this. So again, just a different way of writing this, different form, and from these different forms we can pull different pieces of information. So we're going to go ahead and expand that. We're going to take that same process, but we're going to expand this general vertex form here in the same way. So let's go ahead and do that. So this is equal to, again, we're going to leave the a out front. we're going to multiply the x minus h times itself, because that's what it means to square something. And then I've got my plus k tacked onto the end here. So let's go ahead and do this. We've got first, so inside the parentheses, I've got x times x, so that's x squared. The outer gives me x times negative h, so that's minus hx. The inner gives me another minus hx. And the last is going to give me a plus h squared. And I've still got that plus k on the outside at the end. Simplify a little bit further. So we want to take this, we want to take the parentheses and combine our like terms. I have two xh's here, so we can combine those. So that's minus 2xh plus h squared plus k. And now I can go ahead and distribute this a term. And when I do that, I get ax squared minus 2ahx, where I multiply my a times the second one. And then the a times the third one is plus ah squared plus k. And so it looks kind of funky because we've got all these letters in here, but this is just an equivalent form, just like the last couple examples that we looked at of this original function. This one's in vertex form up here. This one down here is in standard form. Alright, so on this next page, I just kind of condensed some of the information that we found. This is the equation that we just found, and I want to start with the vertex form. And one of the most basic things that we know from the vertex form is we can pull the vertex out of that. So I know the vertex, the x-coordinate of the vertex, is given by this thing in here, this variable, this h, we call it, and then the k is going to give me the y-coordinate of the vertex. So looking at this new equation that we have, it's in standard form. And standard form, when it's kind of condensed, looks like this. There's an x squared term and an x term, and then some number that's usually hanging out on the end, a constant term. But the thing that I want to draw your attention to is this right here. If you look at the numbers in front of x, all of these things should be equivalent. So ax squared is the same down here as ax squared. So the a actually stays the same whether you're in vertex form or standard form. Over here, the number in front of x is different, but we can pull some information from that, and that's what I want to concentrate on. So if these two are equivalent forms, then I know that negative 2ah has to be the same as b. And the point that we're trying to get to is that if you're given a quadratic in standard form, we want to figure out what the vertex of that thing is. We can find that vertex, and it's right here. And we can find that the x-coordinate of that vertex just by solving this for h. So I want to get h alone, which means I want to divide by negative 2a in order to get h by itself. And when I do that, I get this expression. H, or in other words, this is the x-coordinate of the vertex, is equal to the b, or in other words, the number in front of x, divided by a negative 2 times the number that's in front of the x squared term. So I can find the x-coordinate by taking the number that's in front of x and dividing it by negative 2 times the number that's in front of x squared. And this is where it comes from. It's all just from that same thing. It's just expanding that x minus h squared and converting that into a different form. So let's take a look at a couple examples and what this really means in the grand scheme. So the first example, you see this is in standard form. So it's a little bit harder to get to the vertex. We're not able to look at this and just pull the vertex out like we are when we see this vertex form. We can just pull the h and the k out. We've got to do a little bit of work, but that little bit of work is relatively easy. So what I can do is, if I want to find the vertex, I know that the x-coordinate of the vertex is going to be equal to negative b over 2a. And so what's my b? Well, my b comes from the number in front of the x. So the x-coordinate is equal to the opposite of what I see in front of x. So that's just a 4. You see a negative 4, and it's the opposite of what I see in front of that, over 2 times the number in front of x squared. Well, we know there's no number in front of x squared, so technically that number is just going to be a 1. So I know my x-coordinate of my vertex, negative b over 2a, and when I plug my numbers in, a and b and c, the x-coordinate of my vertex is going to be 4 divided by 2, which is equal to 2. So I now know the x-coordinate of my vertex is going to be 2, but I need to figure out what my y is. And the way that I do that is I just plug in the x. So if I take this x-coordinate, it's going to spit out the y that corresponds to that particular x. So that's what we do. We plug in the x-coordinate, plug in 2 wherever we see an x. I know that f of x is really just a different way of saying y equals. So y equals 2 squared minus 4 times 2 plus 3. And if I go through and simplify this, it'll spit out the y-coordinate of my vertex, and I'm done. I've got my vertex. So let's go ahead and simplify it. 2 squared I know is 4. Minus 4 times 2, so that's 8, plus 3. So my y-coordinate of my vertex is going to be negative 1. And then come up here. This is now my vertex. So the thing that's really nice about standard form is that when we go to find the y-intercept and we want to graph this thing, we can use our vertex and we can use the y-intercept to graph it. We find the y-intercept just like we usually do. We plug in 0 for x. And so I'm going to plug in a 0 wherever I see an x over here. So y is equal to 0 squared minus 4 times 0 plus 3. And when I go through and simplify that, I know the first term is just 0, the second term is just 0, and all I'm left with is 3. And so what this means is my y-intercept is going to be 0, 3. If you look back up at this equation, well, that's just this number. So the standard form is really nice if you want to find the y-intercept, because it's just a number that's by itself, or the constant term in the standard form. So let's go ahead and do one more of these. I want to find the vertex first, and when I find the vertex, again, my standard form looks like this. F of x equals ax squared plus bx plus c. And if I want to find the vertex, I start with the x-coordinate. The x-coordinate is equal to negative b over 2a, where b is just the number in front of x. So I go up here and I say, hey, b in this case, the number in front of x is a negative 6. So x equals the opposite of b, a negative 6 is a positive 6, over 2 times whatever the number is in front of the x squared term, and that's a. So this is a, this is b, and this is c. So my a in this case is 3. And so my x-coordinate of my vertex is 6 divided by 6, which is just 1. So I found my x. I got to go find my y-coordinate. And I do that by plugging in 1 wherever I see an x. So let's recopy instead of an f of x. It's the same thing as saying y. So y equals 3 times 1 squared minus 6 times 1 plus 5. And we go through and we simplify this according to order of operations. So order of operations says that I want to square the 1 first. So 1 squared is just 1, so this ends up being 3 times 1 minus 6 plus 5. And then y is equal to 3 minus 6, which is negative 3, plus 5. So my y-coordinate of my vertex is 2. There's my vertex. Last one here, y-intercept. For this is really nice, it's in standard form, so you can go through the process, the normal process, to find the y-intercept, and you can plug in 0 wherever you see an x. But all those x terms are just going to cancel out. So this ends up being 3 times 0 squared minus 6 times 0 plus 5. I know 0 squared is 0, 3 times 0, or anything times 0 is 0, so that's gone. Negative 6 times 0 is just 0. So my y-coordinate, or my y-intercept I should say, y is 5, so my intercept looks like 0, 5. And again, last thing, all we really have to do to find the y-intercept is look at this number up here, and it'll spit out the y-intercept for us.